This is Wentworth Institute of Technology, aka WITAero's 2021 AIAA Design Build Fly competition entry. Our plane name is Icarus. My name is Chris.
My name is Adam.
I'm Nikolai.
I'm Mike.
I'm Ben.
And I'm Paul.
And we are the graduating seniors for the WITAero Wentworth Aerospace Club team for this year's competition.
As you can see here, this is the overall dimensions of Icarus. Chris will dive more into the details at the end of this presentation.
So here are the gross weights of the major components at takeoff, as well as the gross weights for missions 1, 2, and 3, which range from 11.23 pounds to about 12.1 pounds.
This is the control architecture of the plane. The diagram on the left is for the main UAV, and the diagram on the right is for the SDRS deployment system.
The motor used for our propulsion system is the E-Flight Power 160 brushless motor that is powered by a LiPo 6S 4000 milliamp battery. The ESC being used is the Castle Creations 100 amp ESC with a propeller size of 15 by 8 and the capability for watt hours of 88.8. The major components of our aircraft were chosen using the design matrices pictured on the right. The parameters were chosen to ensure the completion of the missions in the most efficient way, and they are weighted individually to reflect the level of impact that they have on the mission success of the missions. The design that received the highest number of total points was the one that was chosen to move forward with.
So based on the trade study results that Adam just mentioned, we elected to go with a modified version of the Lockheed Martin C-130 design, obviously scaled down. And for our analysis, we mainly used SolidWorks flow simulation. And later on in the design, we used XFLR5, which is a AVL-based program.
And these are our projected mission performances. This was based on the original competition rules, and we decided that we would achieve a mission 1 score of 1, mission 2 of 1.37, and a mission 3 of 2.57, which makes us a competitive entry into this year's competition.
As you can see at the bottom of the screen, these are two different prototypes of our sensor design. We used DJI Mavic Mini to take video of flight and then Logger Pro to make scatter plots of their flight patterns. The top one corresponds to the left picture and the bottom one corresponds to the right picture.
We designed Icarus on SolidWorks. Because of this, we were able to use different configurations, such as top mount wings, through mount wings, 2 motors, 1 motors, and several different design concepts for the landing gear. Also, we kept in consideration the size of the SDRS system and the sensor and how it had to be deployed out of the plane. We also used, like Paul said, the XFLR5 program to test the stability of our wings and our rear empennage. After designing Icarus on SolidWorks, we used a laser cutter and balsa wood to create cross sections that were then connected with foams and carbon fiber rods. Spray foam was then used on the outside to make sure the surface was nice and smooth for a carbon fiber process.
Once the cross section was built, we then wrapped it in 3K plain weave carbon fiber sleeve and epoxied it, then cut out the access doors and the door for the sensor to be deployed out, and attached all the empennage, wings, landing gear, and we used 3D printed adapters for the wings and the landing gear.
Here are some still images of our Icarus test flights. As you can see, we tested in all weather conditions whenever we were able to.
With every test flight comes some crashing as well, and at the bottom you can see we track our UAV through its first successful test flight, and due to unresponsive control surfaces, it crashed.
Shown here is the first page of Icarus's drawing package. This is the standard 3U drawing for Icarus. The main dimensions to pay attention to here are the overall length, which is 49 inches, the wingspan, which is 58 inches, and the overall fuselage diameter, which is a maximum at 6.25 inches. Here's an exploded view of Icarus. Some major components to pay attention to here are the wing interface component, the empennage interface component, as well as the landing gear. Each of these components were specifically designed for this competition. Here, we mainly focus on the landing gear, the fuselage, and the wings. These are the main structural systems that support Icarus and enable it to be stable during flight. Lastly, here we also show the empennage, which is the vertical and horizontal stabilizer, our electronics and mission payload layout, as well as our SDRS sensor deployment and recovery system with sensor attach. We are now entering the flight demonstration portion of this video. We are now entering the technical inspection portion of this video where we prove that our plane is what we designed. Here is our 3-view drawing showing our plane, and now we are going to show the plane that we actually built and designed. Here we're going to do a quick little walk around to show it from the majority of all the angles. Really gives a good idea of how it's put together and the overall design and architecture of Icarus. We will now demonstrate the ground mission and prove that the sensor can successfully deploy, operate, and be retrieved. So here we have the SDRS, as we call it, which stands for Sensor Deployment and Recovery System. So here we're going to take you through the paces of deploying the sensor, turning the sensor on, displaying its functionality, and then recovering the sensor. So right now, our teammate Ben is unwinding the sensor to demonstrate the deployment process. We used a 3D printed SDRS chassis, a stepper motor, and a 3D printed sensor. And once it reaches its maximum length, we will then turn on the sensor lights in the pattern that we determined. So we will see that shortly. And here we are about to turn the sensor lights on. And we have red, blue, green, green. And now we will begin retracting the sensor to show the full functionality. And just keep in mind that this process was slightly sped up just to fit the 5-minute time constraint for all of our other videos that we want to include in our submission. And there you can see the tow line gets all the way wrapped up around the spool, and the sensor comes straight back into where it would eventually be inside of the plane. We will now demonstrate the successful takeoff of Icarus. Here you can see our successful takeoff of Icarus, where it starts soaring into the sky. Hopefully it won't crash into the sun. And we're just going to take Icarus through a couple turns, maybe some dips, just to show that we have full control over the UAV throughout the entire duration of the flight. This really just proves that we have flight stability. We will now enter the crash compilation portion of this video. We tried to keep it as PG as possible and still have a little bit of fun with it. We really think that this shows our iterative process of trying to get Icarus to fly. And something else to keep in mind is that we made 3 different prototypes throughout this competition process, and you're going to see those different planes within this footage. We hope that you enjoy.
Ooh. You know what?
Oh. Never.
Oh my god.
I hope it works. Well, that sucked. Oh my god.
We're getting there. Oh my god, it wants to.
Oh!
It wants to.
No. Oh!
It was just
fly. Oh my! Oh! Come on, Ryan! You got this! You got this, Ryan! Damn it!
Flying! It's flying! Haifa, we did it! We gotta fly! Don't crash into that car! Ryan! Oh!
On behalf of Wentworth and WITAero, we would like to thank you for reviewing our video submission, and we look forward to the award ceremony.